Okay, in this video we will explain the Heaviside function and we compute its Laplace transform. Okay. The definition for Heaviside function is if we take a positive number a, then we define the function ua of t to be the function given by the function is equal to 1 if t is bigger or equal than a and is equal to 0 if t is smaller than a. Let's do an example. For example, if we do u4 of t, how is the graph of the function u4 of t? Then it's defined in the whole real line. Here is 4. When t equals 4, since t equals a, then the function is 1. This is 1, right? And then after 4, the function is just a line. And before 4, the function is just equal to 0. Then the graph of the function is like this, right? Why this is useful? Notice that sometimes we have like a switch, right? And then somehow we have a system, a physical system, and all of a sudden we turn on the switch. Then it goes, all of a sudden it goes from one state to the different state. Then things changes like that sometimes. Then for that reason, this function is useful. Let's compute the Laplace transform of this function. Maybe we do the Laplace transform of u4 of t, and then we generalize. What is the Laplace transform of u4 of t? By definition, this is the integral from 0 to infinity of u4 of t times e to the negative st dt. But when we think about this function in terms of t, we notice that for values of t that are smaller than 4, this function is 0, and 0 multiplies something else, it's just 0. And then this integral is just the integral from 4 to infinity. And what happened after 4? After 4, this function is 1. Then I can replace it just with 1 times e to the negative st dt. But we can compute this explicitly. What is this antiderivative? The antiderivative is negative 1 over s e to the negative st from t equal 4 to t equal infinity. If we assume that s is positive, when t goes to infinity, the limit goes to 0. And when t is equal 4, this would be minus 1 over s e to the negative 4 times s. That means that this integral is equal to 1 over s times e to the negative 4s. Okay, then we have this formula. In general, if we change the 4 by an a, we have that the Laplace transform of ua of t is equal to e to the negative as over s. Okay, there is an operation, a transformation that is going to be very useful when we are going to be dealing with this Heaviside function, and it is this transformation. Let's suppose we have the function f of t equal t squared. And for some reason, let's suppose that we only care about t bigger or equal than 0. How is the graph of that function? Then the graph of that function would be like half of a parabola, right? We only care about t bigger or equal than 0. Now, let's think about this function. Let's say the function u4 of t times t minus 4 squared. How are these two graphs compared? This one and this one. Okay. This is the real line. This is 1, 2, 3, 4. What happened when t is smaller than 4? When t is smaller than 4, the function u4 of t, remember that the function u4 of t is like this, 1, 2, 3, 4, and the function is 0, and then after 4 is 1. Then this whole function before 4, when t is smaller than 4, 0 times something is just 0. The function is like this, right? And what happened at t equals 0? At t equals 4, you get 0. 0 is again 0. But then after t equals 0, you can check that essentially when you compare these two graphs, this is a translation to the right of 4 units. That means that the graph is going to look like this. We're going to be calling, in general, we're going to be calling this the original function. And I'll be calling this, in this case, A is 4, the U4 shifting of f of t. And we know that essentially the relation is this. You have a function that starts at 0, and when you do the UA shifting, essentially you are translating that function so that it starts at A, but before A, it becomes 0. Then what I'm doing now, let me just say, I'm defining what I'm calling the UA shifting of a function. Let's do some examples. Then if we have the function f of t equal to e to the 3t, what would be the let's say u6 shifting of f of t? What do we do? The definition is we have the function u6 of t and we multiply by this function, but what do we do? Instead of t, we change it by t minus 6. Then we have 3 times t minus 6. I would like to remind you that the graph of this function, if we care about t bigger than 0, the graph of this function is an exponential function. At t equals 0 is 1, and it's a function that grows like that. And the graph of this function is just, here is 0, here is 6, before 6 is 0, here is 1, and then it's a translation of this function, but making everything from 0 to a equals 0. Okay, then we have that. We need to practice how to move from here, which I'm calling the original, to this, which I'm calling the U6 shifting. Let's do another example. What happens if we have like f of t equal 7? What would be the U2 shifting? Of this function? Essentially, I have to multiply u2 of t, and anytime I see that t here, I change it by t minus 2. But in this case, there is no t, then it's just 7. Then this is the u2 shifting. What about if we have like f of t equal 4 times sine of 2t? What would be the u1 shifting? What do? We do u1 of t times 4 times sine, and anytime I see that t, I change it with t minus 1. And something that is going to be needed, and it's a little more challenging, is what happens if we have the UA shifting and we want to come with the original. Let's suppose that you have something like t minus 2 squared over 4 plus sine of t minus 2. And we know that this is the U2 shifting of f of t. Then the question is, what is f of t? What would be f of t here? This is the U2 shifting of f of t, and the question is, what is the original? Then, according to this, we can see that this would be just t squared over 4 plus, oh sorry, I forgot to say that I have to write the U2t. If you have U2t times this, then if this is the U2 shifting of that function, sine of t. Maybe one last example. This was kind of obvious, but let me do another one that is going to be there a lot. It's like U7 of t times e to the negative 2 times t minus 7. If this is the U7 shifting, what is the original? What is the f of t? The f of t would be e to the negative 2t, because when we produce if this is the original, when we want to get the U7 shifting, we multiply by U7 of t, and anytime we see that t, we replace it with t minus 7. Let me do one last example. What happens if we have like U4 of t times 3t minus 7? How do we find the original? Let's suppose that this is the U4 shifting. What would be the original? Notice that it's easy to tell the original when everything is like is in factor. You have a factor of t minus a. Like here we have t minus 2 and it was U2, and here it was U7, and here we have a factor of t minus 7. Then it's relatively easy, but what can we do here? And as we will see when we are computing Laplace transform, when we are dealing with Laplace transform, rewriting is going to be an important part of this process. Let me rewrite this, 3t minus 7. Somehow we want to have a t minus 4. Then what we do is we rewrite it like this, 3 times t minus 4. I change this t by t minus 4, but if I do that change, I don't want to change the expression. I want these two things to be the same. When I do this change, I'm subtracting 12. Then I just add 12. Notice that this part is essentially equal to this part, then minus 7. That means that this expression is 3 times t minus 4, 12 minus 7, plus 5. You can check that this and this are the same. But now the question is, what is U4 of t of 3 times t minus 4 plus 5? This is the U4 shifting of, what is the original function in this case? The original function would be f of t equal 3 times t plus 5. Okay, all of this is going to be important because in another video I'll be showing that the Laplace transform of UA of t f of t minus a, it is just equal to e to the negative as Laplace transform of f of t. If you look at this formula, you notice that anytime you have an expression like this and you want to compute the Laplace transform, then this part is easy, but then you want to find out what is the original function f of t, so that you can do this. Maybe let me just do an example of this. For example, the Laplace transform of u2 of t e to the 4 times t minus 2. We notice that this is the u2 shifting of what function? What is the original function here? The original function in this case is f of t equal to e to the 4t, right? And according to this formula, this is just e to the, what is a in this case? A is 2. E to the negative 2s times the Laplace transform of the original, which is e to the 4t. And that means that this is e to the negative 2s, and the Laplace transform of e to the 4t is 1 over s minus 4. Then we have computed the Laplace transform of this function that involves a Heaviside function, and it's just something like this, using this formula. This formula is going to be very important. Okay, I think I would like to stop here, because this is it for now.